welcome to another episode of the Contractors Innovation Podcast. Today we have several interesting programmers and Mehdi Heidari, who's got a vision for design software that I was intrigued by and that I think can benefit society and make it quite efficient for many people. So good intentions. Mehdi's a Ph.D. geotechnical structural from Western, where I also went to school. And today we have Kevin Moore. Kevin, can you introduce yourself quickly?
Hey, everybody. I am Kevin Moore. I have been in this industry for about good 8 years, developing websites, web design, web development applications for both iOS and Android, and also web applications. Then I have Arthur here. He is our one of our developers, but he knows ins and outs of creating APIs, connecting different tools together, making web apps, applications, pretty much all.
Arthur, could you give us a minute of your background?
Yeah, sure. I'm developing softwares and tools using different languages, recently known as React, Node. Then for mobile applications, like I use Flutter, and then mainly I'm a modern guy, and then like a full stack engineer. I call myself a full stack engineer, and using these technologies, I used to develop web apps, mobile apps. I work all, I think.
And Mehdi, what's your programmer's name, just for reference, for Arthur and Kevin?
Amin. Amin is his name.
Admin.
Aamin. Amin.
Amin.
Yeah.
So it's unfortunate, but I think he has a class.
Yeah. He has a class. Yeah.
So what we want to do is probably have Mehdi, if you can you can talk a little bit about your background, but also your vision. I saw a very good demonstration when I went to your office. It looked like you actually had a lot of it done. But you also have a background in programming, right, Mehdi? You have many talents, I think.
I've been using different tools for just solving engineering problems. As you know, my background is civil, so usually what I do is write codes to solve a problem. Like usually we use finite element tools or different methods. On the programming side, we can use Fortran. MATLAB is very commonly used tool for engineers. We don't want to get into those back end, front end side of it. We just need to make sure that the results are accurate and the methodology is the right one that we utilize for solving the problem. So from our point of view, the most important thing is to get the right results for the problem. Then if we want to use or create a user interface, and this is what I did during my postdoc and PhD, I used even MATLAB at that time to use the GUI. I create this GUI, for like the other users. The thing is, for the when it wants you want to make something serious, you have to use either it depends if it is the office version or like the desktop version or the web based. We worked on some web based tools as well, and the desktop version we created this use C# for a reason. I will tell you why we used C# at that time. We had to use C# for that application. So we converted everything to C#. We created this desktop version. Eventually, at the same time, decided to go on a web-based tool as well. So the same version of the same tool, but web-based tool. We created something web-based as well. But as you know, we have lots of things involved. The back end, front end part. We converted all the engines, function, everything. We had to validate everything again and again to make sure that the results are accurate from the engineering point of view. But on the workflow side, I came up with a workflow for that tool or software that we have developed. But if we want to go with something like that can be used by other users, we need something that more user friendly, more interactive, use the right tool, the right approach. Unfortunately, the person that I hired for almost 1.5 years, he was a good programmer, but very junior. Didn't have the vision. The most important thing is the vision.
Of
If
course.
you don't have the vision when you develop a tool, it works, but for 10 users, if for 2 years, then it shut down. It doesn't work afterward. So you can't expand it. You can extend the tool, the capabilities, users number, this and that. It crashed down. So for many reasons, I learned that you have to use the right team to do the right things.
Exactly.
If the person they should have this eagle eye from they should see all the different aspects, not about solving a specific problem. It can be done with any language, as you know, but the other aspects of developing a software is more important.
Of
My
course.
humble opinion.
Now, I do have a question here, Madi. What language do you use for these tools for the web application?
React.
React. Okay,
Yeah.
good. Yeah, we can work
Yeah.
on it. So, I have watched a couple of the podcasts where you have explained a little bit about what you were doing with the data from the soil samples and drilling.
Yeah.
And so what I was thinking, this was my grasp on it, that it's like different tools, but you wanted them to come together as an application. And then, maybe, after inputting all the data, it should give you like a 3D model of it.
This can be part of it, right? On the
Yeah,
visualization side. On the
exactly.
analysis side, there are different applications on the analysis side. You can do a slope stability, this, that, shoring design, and Martin are expert in this field. Like these different applications from foundation design to pile design, shoring, this and that. This is the application side. On the report generation side or analysis side for field investigation, there are lots of applications on that side as well. So there are rooms to expand the applications. One of the key challenge at that time was to come up with a workflow for this tool, different steps how you do it, because one of the most like probably shortcoming in our world is this is geostructural world is the gap. There is a gap between the structural tools and geotechnical tools.
So it's like the alignment of the tools as how it should be as per what should come next after inputting a data on a certain tool. Then it'll take you to the next tool and what tools should comes after that. That's what you're talking about.
Yeah, the
Yeah,
person who develops a geostructural should have a good grasp of a structural and geotechnical side of. I'm not talking about theory or analysis part, the modeling software,
gotcha.
the programs that they've been using for years, like the program that structural engineers use are different than the one that Geotech uses, right?
Mhm.
And on the modeling side, we have different tools for modeling as well. Like, I teach a course like it's a Revit, and I used to use AutoCAD, which is for drawing. some of these tools are drawing based, not objects based.
Exactly.
So this is a thing, some of these tools, they call it BIM enabled software.
Uh-huh.
In building information modeling,
Yeah.
BIM enabled software. So some of these tools, so I was trying to combine the best or pick the best options, capabilities of different tools, and come up with something that is robust enough to cover most of these. And at the same time, it's familiar to those who are going to be use it at the end of the day. It could be geotech or a structural or a combination of both. So the way that they were thinking, structural engineers and geotech are thinking, are kind of different. So that's why we need to have that vision, how to bridge between these two different fields.
Gotcha.
On the interface side, I'm not talking about the theory or the analysis side of it. The vision to know who will be eventually using this tool, right? So on the interface side, so the way that they are familiar with, like, CSI tools like eTabs or some of these structural ones, they have to define and then assign, define material objects, this and that, and then assign it to different objects, right? But in geotech tool, different, they think differently. They came up with
Gotcha.
different. So this is what I was trying to do. The workflow was one of the backbone of the tool, the software. How to implement it? There are a million ways to do it, and I know that if you don't have, on the programming side, if you don't have the vision, eventually we get into some trouble.
Of
We
course.
we can't expand or extend the software beyond a limit. So that was the I think something that I wanted to actually discuss and get your feedback on. One of the things that I like to also know, if you don't mind, if you can send me something, especially on the web-based tools, the applications or apps that you've developed. Like, I want to see what features you have included, because at some point I like to have some 3D type of navigation tools
Of
or
course.
capabilities in that. And yeah, this is something that I like to also include eventually. When we collect all the data, eventually I like this to be kind of the way that now we do it in my version of the web-based tool. We feed even for the geometry, we don't draw or create the geometry. We feed input, and then we just have limited capabilities on the drawing side. How are you gonna do that? What are the options? What is the best way? You know what I mean? So we need to figure this out. At this point, it is just feeding inputs. Like, you just imagine you want to draw a box, right? You can
Gotcha.
pick 4 points, right? Or you can draw 4 lines, and this is gonna be your box or your rectangle. Or the user you can get the XY coordinates of 4 points. We just get the coordinates at this point. We don't let them to draw anything
Draw
there.
it. Okay.
So these are some of the things that I'm thinking. If we develop the software just to get information from the user, easy. We do the hard work behind the scene, but it's very limited to certain type of geometries. You
Gotcha.
give them option to draw, then there are different reasons that they make a mistake, and we get into trouble, right? We have
Yeah,
to do lots of checks.
because it's going to screw up the data that's supposed to be there. Yeah, I'm getting it.
So these are the challenges we need to think and discuss if we wanted to pursue. But I like to see what are what you have done like on different applications and
Of course.
yeah, on the interface side, on the like the different
Backend.
features that you have included.
Mm-hmm.
And then yeah, and I appreciate your time and thank you, Martin, for scheduling the meeting today. Martin,
Do you think you could give us a sample job? I'm just going to suggest practically.
Yeah, I mean, I can surely.
Not
Go ahead, sorry.
from you, Kevin. I'm talking about
Okay.
Mehdi. But let's say Mehdi that you created a shoring wall with two three elevations, three-dimensional box. Typically, foundation work is depth and length and width of on a street corner, let's say a city block. So you end up drawing four elevations, and each elevation may really be varying on depth, but also, from that, there's sort of an initial geometry. So that I think exists in CAD now, correct, Mehdi, in terms of people who like if you do slope stability, or let's say excavation support, like with a Matt Janes or somebody, we could get a couple of sample jobs from Matt and then try to use those as sample jobs. I don't know, like because you
no,
don't use. Go ahead, Mehdi.
what I was trying to explain is this. When you want to define a geometry, you can let the user to just provide 4 points for a rectangle, or you can let the user to draw those 4 points. These are two different approaches, right?
Right.
I'm not talking about the analysis side. I'm not talking about assigning material to this box or whatever. I'm just talking about getting information from the user. It could be through an interactive like drawing graphic like capability that you can provide, different tools or different like React or any of these tools. But we need to see how advanced it's gonna be. You know, do you want to make it very basic or highly advanced? There are pros and cons for each, but I like to like discuss those and see what is the most practical way to do it and the most
Of
efficient way
course.
to do it.
Yeah,
You
what I think is like you may need to, have a limit to it. Like, like let's say when they're drawing for the four corners, it would have to be there. It has to be a formula that's going to restrict them from, overdrawing or, restrict them. Yeah. So there
Absolutely,
has to be a
yeah,
formula.
yeah,
Yeah.
yeah. But I'm just talking about like the because you don't have these are like these all these can be done easily, right? You know, different.
Oh,
But
yeah.
we need to like this is one only aspects of that. I mean,
Yeah, exactly.
programming part. You know, we
Yeah,
can discuss all the other details as well, but I'm just talking about like this is one example of like 100 probably.
of course.
But but the thing that my main concern is I want to make sure that the person that I work with has enough experience and background is in implementing all these, because you can but it takes forever, right? You can just try and learn and see how I can do this and that. Like if I want you to orbit the model and then cut a cross section for a reason that I am interested in, right? If you have done this before, it makes life way, way, way easier than
Easier.
just trying to find a way. Because if you don't have that end use in mind from the start, the beginning, then what we end up with? We develop something, but you don't have that orbit option.
Exactly. Then we would spend much more time on it, redoing it. I,
Exactly. You
yeah, I
got it.
totally get you. I totally
Yeah.
get you.
Yeah.
Mehdi, I got a comment. Why don't we just use AutoCAD as a base? Because
You
AutoCAD
you
is go
this
ahead.
is what we did. You can, and this is what you can do. You can get data from other tools, extract them, and then redo, because eventually you have to redo it for the analysis part. This is the analysis, but behind the scene, we have an engine, and this engine needs data to be run, right? To get run. So the thing is this: yes, you can use different tools for like geometry, creating geometry, but do you really want to use AutoCAD to create the geometry, export it to your software, then read the data, and then from there you plot them in your software to do what? To just draw some lines? So the thing is, and you need two software now. The person who uses AutoCAD needs to get a subscription for AutoCAD, 5,000, and then just to draw, because
But but
AutoCAD
but
does not do the analysis for you, right? It's just a drawing tool.
but most users have that AutoCAD defined. Like there's a lot of AutoCAD users.
Nope,
So
not in none of the tools, in no engineering tools. They use AutoCAD. You can use it, but engineers never ever use AutoCAD unless you have a very sophisticated like geometry. If you look at Plaxis, rock science, any structural or geotechnical tools, they let you, they allow you to draw the geometry, because you want to do everything in one shot, in one tool. It's not a drawing tool. It's not about drawing. We don't want to create a drawing tool. We want to create an analysis tool. It's an engineering tool for analysis. For that analysis, you need to draw the geometry.
so one thing I'll comment on, like if I'm doing excavation support, typically I'll draw a line and show a depth. And then you get into the idea of having layers of soil. So you can see how it turns into a 2D problem,
Mm-hmm.
typically.
Yeah.
And the 3D less important, Kevin. But the 2D problem is kind of what I saw the day I went to Mehdi's apartment or his house. You know, he had what was very familiar to me, layered soil, and then each layer might have properties, and then the whole thing can be almost translated into any size project. But basically, you take a slice. So that slice might be a way to help you think, Kevin, in terms of
Yeah. And it's even 1D, because these layers has only have depth. They don't have length.
right.
It doesn't matter in our life. On geotechnical side, we don't care. But if you have a slope and you want to perform a slope stability analysis, then you must go and do the geometry. In my version, I just have one simple geometry for a slope. I just have this slope. You can't just do this. You provide the height, the length, the angle, and we create it. But if you have a irregular slope, you can't do it. This is what I was talking about, creating or allowing the user to create something, the geometry.
Gotcha.
Obviously, for some problems, like if you want to design a footing, like it's sitting on layer of soil, it's even 1D, it's not even 2D. They don't need to design or define anything. It's just, layers of soil, provide the geometry for this, and then we create everything for you. We show you, this is what I do now. So I get the information and I plot. Like you give me the depth and height and dimension. I plot everything for you, and you can even visually see what you are solving, right?
Uh-huh.
But it is good at some point to let the user to draw, because some users wants to draw a more complicated geometry for a slope stability analysis. And it is the only application that requires that Why 3D? There is an application that I have in the back of my mind that I'd like to have that 3D. I don't want to get into the geotechnical engineering part of it. I know that Martin will appreciate it if I tell him now, but I don't want to open this, wormhole and, talk about all the different holes, But one of the application is like this. You have like 3, 4, 5, 10 boreholes with all the soil data. One of the most time consuming part in geotechnical is and hydrogeology is to connect these to come up with a stratigraphy. We call it layering of the layers of the soil, and you have water level, and you can also provide the water table in monitoring wells. So in a 3D view, you can connect these points and kind of get a grasp of soil layering and water table direction and the gradient or the slope of water, things like that. So that was one of the reasons that I want. It's not too complicated, to be honest, but it helps a lot in visualizing how layers of the soil can overlay each other.
Yeah, because the layering of the soil is different.
But this is
Yeah.
advanced application. This is an advanced application. This is like ultimately we're gonna get there if we want to, But at this point, no, it's not required. Just even
Okay.
1D, not even 2D is more than enough. All you need to do is provide to, and this is what we do now. We get the depth of each layer, just like different lines, right? 1, 2, 3, 4, 5, and done.
Okay.
So Arthur,
Getting-
it'd be, to explain it to Arthur a bit, it'd be like typically soil, let's say in Toronto, you'd have 15 feet of fill left from people leveling the ground and we call it fill because it's not naturally consolidated soil. The soil in North America, or at least around the Great Lakes, is glacial soil, so it's had compression from glaciers. So you call it certain value of soil. So it'd be stiff clay or hard clay, but defined by certain parameters. So those layering would be very common. And I think Mehdi will get 80% of what he's already got from everybody just creating a program where you can vary the depth of the soils, right? And then when you go to the third dimension, it might be a hill that has a back slope, or so you end up with these different grades, different properties of soil, but generally it's all clay. And but of course clay can get down like in Toronto when you go. It's interesting when you go to Front Street where the Sky Dome is. The Blue Jays are playing tonight, actually. So that's built on rock. I actually did the Sky Dome many years ago, and it was a very easy job to do. Now there's been certain agencies that got involved worrying about groundwater in Toronto and changed regulation. But for the most part, there's no water. And if you excavate at the Sky Dome, you go right to rock. Like in 20, 30 feet, you're on shale rock, which has got a geological history that might give it, 75 tons a square foot working pressure. So you get these soil parameters that I think, Mehdi, you would want to have the ability to change parameters and geometry, right?
Yeah.
Yeah.
This
Are
is
you
one of the job site that we are at. This is what we are talking about. You see,
Perfect. Yeah.
different layers. And what is that?
So you're on billable time, Mehdi. You're getting paid right now.
Yeah.
You're going to need it.
Yeah, I am in the job site. I have to do some investigation here. Just inspecting the site. I don't know what I did. I hit one of these bottoms.
So I have a quick question, right? Because Martin, you're talking about, there's different clays and different soils. Do those already have like predetermined, like you said, values? Like all of this kind of clay is labeled as an 8, as an example. I don't really know what it would be, but does that make sense? Are
Don't need
Yeah.
to
soils
get
like
into all these details. You don't need to get. Provide all the like information on that side.
Mhm.
You just need to focus on the engineering side, like the
Yeah,
sorry,
yeah.
the coding side.
Yeah.
Typically layers and historical history to how the layers were laid down, you know.
Oh, okay.
So it's
Okay.
the layer, and then the geotechnical might be something
Yeah.
called blow counts. You drop a hammer, how many blows do you get in 1 foot?
This is for
So
the
that,
loading area, huh?
yeah, you'll become an
I
expert,
proposed like
Arthur, at
5. That's why you look at this.
it's pretty easy. Civil engineering is pretty easy.
How deep? Like this is where we got the native, huh?
Yeah, that's my native.
Yeah, and all this are
This is actually pretty good.
liquefied sand. You see that, Martin?
Liquefied sand.
Yeah, this
So
is like
so
loose
that's
sand filled with water, and
is
it's
that
like
because it's silty? Silty is
yeah,
always pulls the
silty
water
sand.
up.
Yeah, yeah,
It's a finer grain than sand, yeah.
yeah,
Makes for a muddy site.
yeah. This is how deep they excavated this site to
Which
find
site
it.
is what is this, Mehdi? Is it somebody who tried to take some obstructions out? Like why did they
Oh, this
excavate?
is this is a job site. We are at it. They wanted to do some building, and the soil is not good. They want to excavate this and replace it with some granular crushed stone, and then we're gonna put some compacted granular.
Yeah.
So would you it's not you're not gonna put helicals? What are you building there? Like screw anchors are called helicals, Arthur.
Yeah, yeah, helical, yeah.
Like
No,
just
not
like a
helical. This one is we're gonna go with CFA pipe and bearing
oh,
pipe because it's the helical are like kind of side friction. Those not side friction. The helix, is kind of end bearing, but it should go. We're gonna go with end bearing pipe.
end bearing?
Yeah, a
Because
CFA.
CFA, yeah, I like
Yeah,
CFA.
yeah, CFA.
It's a very
And
good
Martin,
pile.
do you mind if I leave the meeting because I have to go
Yeah.
at this point?
How many
No?
minutes do we got so far, Dante?
We're at 35, so we have like 5 minutes left, six
Okay.
minutes.
Yeah.
Okay, Dante or Mehdi, thank you, eh?
All right. Thank you. Take care, boy.
Okay,
Thank you.
bye.
All right.
So we'll record 5 or 10 last
Yep.
minutes. So that was actually useful.
Oh,
Yeah.
yeah.
And Kevin and Arthur, we'll get down to brass tacks in the next meeting, I guess. If Mehdi's got, I think he should have a look. Maybe Mehdi has to do it from home, but show us the drawing that I saw when I first went to his house,
Mhm.
which shows the layers and
Yeah.
I think we need to have another probably an hour,
Yeah, I think because I
and
think what would
get some
be
more terminology and some more lessons, Dante.
yeah, like I think because he's on that site right now, so in my mind, I'm like, if he's doing like a site survey or whatever, it's like he's there right now. What information from that site would he want to input in his program, right? Like he's like, okay, I gotta collect, like you said, the silty soil, it's this and that. You'd write it down and just like feed it into the machine,
Well,
you know?
typically he'd be doing the 3-inch hole is called a borehole,
Yep.
and he can do a hole. And when he goes down in the borehole, he can drop a weight. It's called an SPT test, and he can get
Okay.
so many blows in a foot. So then after a while, if you're working with it, you'd say, "Oh, I understand what 30 blows per foot soil is like,
Okay.
and what bearing it can take." So if there's certain things, SPT values, or let's say layering, it's going to be that kind of three-dimensional problem in the end.
Yep.
What's the civil structure you're trying to end up with? If it was a retaining wall permanent, we would assign certain permanent values for belt and suspenders. Whereas if it's a retaining wall temporary, let's say just to build a parking garage, 3-4 stories, you put in excavation support temporary, and then you try to get a straight line, and then you put a concrete wall in front, and you use the floor slabs of the garage, the parking garage, which gives you a lot of strut support. But you have to put temporary strut supports in the temporary work situation. So is it permanent or is it temporary?
Mhm.
So I think Mehdi needs to show us a couple examples from his computer
Yeah.
and probably have a stage 2 to this podcast.
Yeah.
Yeah, I
what-
mean,
Yeah.
if he's available tomorrow, because since tomorrow is Saturday, I would love to join in and
Do
take
you
it further.
Do you think Saturdays is a good time for? I'm okay for I can get on my phone, but like
I'm
it
booked
depends a
tomorrow.
bit. Yeah, so we
Oh.
got to get the podcast guy because
Yeah.
he's going to put this up, and we can get a lot of mileage out of this.
Yeah.
Arthur, you'll become famous. Anyway,
Yeah, that's good.
Arthur's a good-looking guy, eh?
Oh, yeah, he is.
He's
Yes,
Still
so
young.
He's young. Are you married, Arthur?
No, not yet.
Yeah, don't get married. Anyway, that's a long story.
I think after marriage, your hairs are going to be white. That's
Yeah.
why you're suggesting that.
After 2 marriages.
Oh,
Kevin,
Yeah.
have you been married once or twice?
Just once.
And you're still married? Or?
Yeah, I'm still married.
Oh,
But
that's
it's
good.
it's enough.
Yeah.
More than
It's,
enough.
it's enough to get your hairs white.
Oh, yeah. Definitely.
Anyway, the pleasure meeting you, Arthur.
Yeah.
And Kevin, nice to see you again. And
Yeah.
Baby, I need to know.